Hello students, welcome to Breedmark Academy. Myself L.S. Nanda. Now in this particular video, I am going to discuss the detailed solution of fifth question of free maths mock test for JEE Main 2026. The question says two circles are given as follows. C1 x square plus y square minus 2 into inside the bracket 2 alpha minus 1 into x outside the bracket minus 2 into inside the bracket 2 alpha minus 3 into y outside the bracket plus 8 alpha square minus 16 alpha minus 54 equal to 0, and C2 x square plus y square minus 2 into inside the bracket 2 alpha plus 1 into x outside the bracket minus 2 into 2 alpha plus 3 inside the bracket into y outside the bracket plus 8 alpha square plus 16 alpha minus 1014 equal to 0. Then the absolute sum of all possible integral values of alpha for which the point P 3, 1 always lies strictly outside the circle C1 and always lies strictly inside the circle C2 is. Now students, I will solve this question by using a basic concept of circle, and that is, if suppose s equal to 0 refers to the equation of the circle in standard form, and we have to test whether the point P h, k lies inside this circle or outside this circle, then what do? We put x equal to h and y equal to k in the expression s and call this quantity as S1. If S1 is positive, then we say the point lies outside the given circle, and if S1 is negative, then we say the point lies inside the given circle. Now let's move further and solve this question. Now students, the equation of the circle C1 is given as x square plus y square minus 2 into inside the bracket 2 alpha minus 1 into x outside the bracket minus 2 into inside the bracket 2 alpha minus 3 into y outside the bracket plus 8 alpha square minus 16 alpha minus 54 equal to 0. And it is given to us that the point P 3, 1 strictly lies outside the circle C1. So as per the concept, we will just put x equal to 3 and y equal to 1 in the equation of the circle C1. So we get 9 plus 1 minus 2 into inside the bracket 2 alpha minus 1 into 3 outside the bracket minus 2 into 2 alpha minus 3 inside the bracket into 1 outside the bracket plus 8 alpha square minus 16 alpha minus 54. And as per the concept, this quantity must be greater than 0. Now let's do the calculations. It becomes 10 minus 12 alpha plus 6 minus 4 alpha plus 6 plus 8 alpha square minus 16 alpha minus 54 greater than 0. Now it further becomes 8 alpha square minus 32 alpha plus 22 minus 54. So this becomes minus 32 greater than 0. Just divide this equation throughout by 8. You will get alpha square minus 4 alpha minus 4 greater than 0. Now students, we will factorize the term on the left hand side of this inequation and use Weaver method to get the range for alpha. Now students, to factorize the term on the left hand side of the inequation, I will use discriminant formula. So from that we get two values of alpha as 4 plus minus square root of 32, which is 4 root 2 whole divided by 2. That means two values of alpha are 2 plus minus 2 root 2. So the factors are alpha minus 2 plus 2 root 2 and alpha minus 2 minus 2 root 2. And this particular quantity is greater than 0. So as per Weaver method, alpha is either less than 2 minus 2 root 2 or greater than 2 plus 2 root 2. Now students, do not jump to say that this is the final range of alpha for the first condition, because it might happen that the radius of the circle C1 is dependent on alpha. So first of all, we will have to find the radius of the circle C1. I am calling it as R1. It becomes square root of 2 alpha minus 1 whole square plus 2 alpha minus 3 whole square minus inside the bracket 8 alpha square minus 16 alpha minus 54. And this becomes square root of 8 alpha square and 8 alpha square, they get cancelled, and we get minus 16 alpha plus 10 plus 16 alpha plus 54. So this finally becomes square root of 64, which is just 8. So that means this is the final range of alpha for the first condition, right? Because radius of the circle C1 is independent of alpha. Now students, we move further and find the range of alpha for the second condition when the point P 3, 1 strictly lies inside the circle C2. Now students, the equation of circle C2 is given as x square plus y square minus 2 times inside the bracket 2 alpha plus 1 into x outside the bracket minus 2 into inside the bracket 2 alpha plus 3 into y outside the bracket plus 8 alpha square plus 16 alpha minus 1014 equal to 0. Now since point P 3, 1 strictly lies inside the circle C2, so we will just use that concept and put x as 3 and y as 1 in the equation of the circle C2. So it becomes 3 square plus 1 square minus 2 into inside the bracket 2 alpha plus 1 into 3 minus 2 into inside the bracket 2 alpha plus 3 into 1 plus 8 alpha square plus 16 alpha minus 1014, and as per the concept this quantity must be less than 0. So that means we get 10 minus 12 alpha minus 6 minus 4 alpha minus 6 plus 8 alpha square plus 16 alpha minus 1014, and this quantity is less than 0. Now students, minus 12 alpha and minus 4 alpha becomes minus 16 alpha, and it gets cancelled with 16 alpha. So we get 8 alpha square minus 1016 less than 0, or alpha square is less than 127. That means mod alpha is less than square root of 127, or I can say that alpha is greater than minus square root of 127 and less than square root of 127. Right? Now students, we move further. Now students, we will find the radius R2 of the circle C2. And this comes as square root of 2 alpha plus 1 whole square plus 2 alpha plus 3 whole square minus inside the bracket 8 alpha square plus 16 alpha minus 1014. So just do the calculations. 8 alpha square and minus 8 alpha square cancel each other, and we get 12 alpha plus 4 alpha, which is 16 alpha, then minus 16 alpha plus 9 plus 1, which is 10, plus 1014. So this is nothing but square root of 1024, which is just equal to 32. That means the radius of the circle C2 is also independent of alpha. So I can finally say that the range of alpha for the second condition is alpha greater than minus square root of 127 and less than square root of 127. I am calling this as the second inequation. The first was alpha less than 2 minus 2 root 2 or greater than 2 plus 2 root 2. This is the first inequation. Now students, to get the final range of alpha, we will take the intersection of both of these conditions, right? Let's move further. Now students, after taking the intersection of these two conditions, we finally get the range of alpha as alpha greater than 2 plus 2 root 2 and less than square root of 127. And the second possibility is alpha greater than minus square root of 127 and less than 2 minus 2 root 2. Now we know that square root of 127 is 11 point something and root 2 is 1.414 and so on. So that means 2 plus 2 root 2 becomes 4.8 something and 2 minus 2 root 2 becomes minus 0.8 something. So clearly for the first case or the first interval, the permissible integral values of alpha are 5, 6, 7, 8, 9, 10 and 11. And for the second interval, the permissible integral values of alpha are minus 1, minus 2, minus 3, minus 4, minus 5, minus 6, minus 7, minus 8, minus 9, minus 10 and minus 11. And we have to take the absolute sum of all of these values. That means first of all we have to take the modulus of all of these values and then add them. So clearly this is equal to 1 plus 2 plus 3 plus 4 plus 2 times of 5 plus 6 plus 7 plus 8 plus 9 plus 10 plus 11. Now this becomes how much? This is 10 plus 2 into how many values are these? These are 7 values. So just apply the formula of AP. 2 into 7 by 2 into 5 plus 11. So this becomes 10 plus 16 into 7, that is 112. So finally this is equal to 122. So that means option C is the correct one. Now students, in my tomorrow's video, I will discuss the detailed solution of the 6th question of free maths test which I have posted just now. If you haven't watched that video, please watch that video as well and practice these questions for your JEE Main 2026 exam. They will definitely help you in achieving good rank. So keep watching my videos and enhance your knowledge of mathematics. Thanks.